So here we go, 107, domain, range, mappings, and all sorts of interesting things. So if we look at part A, we're trying to find whether the mappings are one-to-one, many-to-one, one-to-many, or many-to-many. Well, taking the first graph, we can see that there are many values of x mapping to one value of y. Let's call this first one, we might call this x1, we might call that x2, and both of those are mapping to this same value of y, so that's many to one. The second one is one to one. The third one is many to one, but similarly to the first graph. And the fourth one is one to many. We might have this one value of x mapping to many values of y. So there's the confirmation of the part A of the question. Now we have to decide whether the graph could represent a function or not. Well, the only one that can't be a function is the fourth one, because this is mapping to many values of y. And so that can't be a function. We have to be a little bit careful with the second one, because although for the part of the x-axis or the set of values of x for which this function is defined, it maps to these values of y. So for that domain, it's a function, but it's not defined for any other values of x. So as long as we define the domain, then that would be a function. So there we are. The only one that's not a function is number 4. Now we have to decide whether the function has an inverse. Well, you may already know that a function can only have an inverse if it is one-to-one. So there we are. Number 2 is the only one that has an inverse. So that's the answer to that question.